Okay, now question number 15. The speed time graph for a falling skydiver is shown below. As he falls, the skydiver speed spreads out his arms and legs and then opens his parachute. Which part of the graph shows the skydiver falling with terminal velocity? Terminal velocity is the constant velocity, and terminal velocity is achieved, you can see, like this is the starting point when it has zero velocity. When it jumps, then initially its velocity is initially its speed is increasing. Might be the speed is getting constant here, like decreasing, because I think he spread out his arms and legs, like its surface area is increasing, resistance is increasing, so its speed is decreasing here, not going in like this. Speed is not going like this, speed is decreasing just because of his because the skydiver has, like the skydiver spread out spread out his arms and legs. Then, like this is like why the velocity is dropped here. The reason is, like at this moment when the skydiver opens his parachute, then suddenly its speed or velocity is decreased, and this is the sudden decrease in velocity. So a time like after this, after some time, like you can see, like the velocity is getting constant here. This constant part of the speed or velocity actually represents, this constant part actually represents the terminal velocity of the object. So our option is this one. This is our correct option. The diagram shows speed time graph. The diagram shows speed time graph of motion of a car for 4 seconds. So you can see 0, 1, 2, 3 and 4. These are the 4 seconds, and this is like a speed of the object. What is the distance traveled by the car in 4 seconds? So we know that there are two possibilities. Either you can use the trapezium method, or you can split this diagram into two parts. Like the left one is triangle, the left, this portion is your rectangle, this one is your rectangular part, and this one is your triangle part. Or you can, like you can solve it as a single diagram, which is trapezium method. So I am going to use the trapezium method. Yeah, if any one of you is interested in like this split method, you can like he or she can use. So trapezium is, you know that the area under the graph is actually the distance traveled by the object. So for trapezium, 1/2 sum of parallel sides. So in this case, like this side and this side both are parallel to each other, like the time, like in this case time side, like it represents time, it also represents time because speed is constant. So this is parallel with this one, so I'm going to use this one. So it is 1, from here to here it is 1, here to here it is 4. So sum of parallel side means 1 plus 4 multiplied height. Height is actually the line which actually connect two parallel sides. So this one and this one are parallel, so it actually connects the parallel sides. So this side is height, so height is 5. So oh, height is 10, sorry, actually here is 10, so I misjudged. So this is cancelled with this one. So we are left with 5 times 5, just 25. So our correct option is this one, and these are the wrong ones. So in question number 17, an object moves from P to Q in 10 seconds with uniform acceleration. Velocity at P is 5, velocity at Q is 12. Velocity at P is 12 and velocity at Q is 5 and 12. What is the acceleration? You know that acceleration is, so this is our V, this is U, this is V, and this is your time. So we know the formula V minus U over T, which is our acceleration. So V is 12 minus 5 over 10, and it is 7 over 10, and it is 0.7. So our correct option looks this one. And the rest of them are incorrect. Now number 18, the graph shows how the height of an object above the ground changes with time. Okay, so you can see at 0 second the height is 4. 1 second the height is reduced to 3. At 2 second the height is reduced to 1. So let's mark them. Okay, so these are like at 2 second it is 1, at 1.5 second it is 2, at 1 second it is 3, at 0.5 it is 4, like at 0 it is 4. What is the terminal velocity? terminal velocity is when the you can say when it would become constant. Total distance over total time remains same. So you can see it looks after this time approximately here there is a constant decrease in time, decrease in height. After this portion there is a constant decrease in time, and you know that the gradient of distance time graph is actually the speed or velocity. So we can take, like, suppose if I would consider this point, I'm going to consider this point here. X-axis is 1 for this point, x-axis is 1 and y-axis is 3. And for this point x-axis is 2 and y-axis is 1. So now if I would calculate the gradient, what would be the gradient? y2 minus y1 over x2 minus x1. So y2 is, suppose, 1, x2 is 3, similarly x2 is 2 and y2 is 1. So it would be minus 2 over 1, which is equal to minus 2. Okay, so actually the direction actually represents the decrease in height. Okay, now our answer is 2, so the correct option looks this one and rest of the options are incorrect. Okay, so question number 19 says the speed time graph represents the journey of a car. The dots separate different sections of the journey. There are 6 different sections. So okay, this is section number 1, section number 2, section number 3, section number 4, section number 5, section number 6. Okay, how many sections represents the car moving with non-uniform acceleration? So you can see here is non-uniform acceleration maybe, and here also it looks that the acceleration would not be, acceleration or deceleration may not be uniform. So for me I think there are two portions where acceleration is non-uniform, so rest of the options are incorrect. Question number 20. A steel ball is released. A steel ball is released just below the surface of thick oil in a cylinder. During the first few centimeters of travel, what is the acceleration of g? Like a ball is put into some, actually okay, So here it is mentioned that the first few centimeters, it means initially it will accelerate with like with gravitational acceleration. It would be under the influence of gravity. So constant and equal to 10 meter per second square. So with the passage of time, there would be some changes, but first few seconds it would be with kind of it would be a kind of gravitational acceleration. Okay, so next is, a cyclist travel along a hilly road without using the pedals or brakes. Air resistance and frictions are negligible. The speed time graph of the cyclist is shown. At which point did he reach the bottom of first hill? So you can see, question is, at which point did he reach the bottom of the first hill? Where is first hill? Okay, so now you can see, suppose if we consider this smaller one as a hill, this one as second hill, and this one as a third hill. So all of them have D as a D would be their bottom. It looks that D would be the bottom. I think so. Okay, so in question number 22 it says, a ball starts to roll down a steep and down a steep slope and then along rough surface. So it means a steep surface would be something like this, and then we have rough surface, and rough surface would be okay. Suppose a ball is rolled down, so let's draw a ball which is rolled down from here. Okay, so when a ball is rolled down, you can see till here the velocity will increase, a speed will increase. After this, due to friction, the speed of the ball will decrease. So we will have two portion in a graph. Till here the graph must have an increasing part, and after this the graph must have, like during this portion, the graph will have a decreasing part. So I think the most suitable graph would be D. And D is the correct option, and I think these are incorrect options. Okay, let's move to 23. A car is stationary. A car is stationary at a set of traffic light. Okay, during the green traffic light. When the light turns green, okay, signal is green. The car begins to move and continues with the speed up till it reaches the maximum speed. Okay, so it means the graph would be something like this, increasing and maximum. Okay, this is the suppose maximum part of the velocity or speed. It continues to travel at the constant speed for the rest of the journey. For rest of the journey it will continue with the same constant speed like this. What happens to the acceleration and the velocity of the car during this journey? So during this journey, like after this part, like neither the velocity, like you can see the velocity is constant velocity means acceleration is 0. So option D is correct, because neither the velocity is changing nor the acceleration is going to change. So the correct option is D. So these are incorrect options. Question number 24. A table tennis ball is released from the top of a evacuated tube. Evacuated tube means there is no air. Which graph shows how the speed of the ball changes with time as it falls to the bottom of the tube? Okay, so you can see when the ball is allowed to drop down, like this ball is allowed to drop down, there is no friction force, so it will move with like it will move with a uniform velocity, like its acceleration would be gravitational acceleration like this, and with gravitational acceleration means there is a constant increase in velocity. And for me, I think this one would be the correct option, because it has uniform velocity graph, velocity time graph. Okay, next is the speed time graph for a car is shown. Okay, what is the acceleration of the car at 30 seconds? So let's check where is 30 seconds. 30 seconds is somewhere here. Okay, so I think like both uh, okay, so there is a technical thing in it. So you can see the velocity is increasing at this time. The direction is reversed. Oh, so the velocity is going to decrease after this point. Like after this point the velocity is going to decrease. So for the question is about 30 seconds, so we can choose like this point and this point. How much is the increase in velocity or increase in velocity? So here is 30, here is 5. 30 minus 5 is 25. Either you can choose this one, like the acceleration would be this one, 25 over 30. actually this is the formula, like the C is a solved, C is solved one, and B is not solved one.